linear inequalities in one variable. An inequality is a way of indicating a set of numbers satisfying a condition. For example, here in Kentucky, individuals must be 21 years or older to legally purchase alcoholic beverages. Now, rather than saying you have to be 21 or 22 or 23 or 24 or 25 or 26 and just listing all the possible ages, plus you never know when to stop. Okay, do you stop at 100? Do you stop at 105? We just say that age is greater than or equal to 21. That just gets all of the inequalities together, and that indicates who can purchase alcohol. Now, linear inequalities have many things in common with linear equations, and just before we get into that, let's just remember what a linear equality looks like. When you have ax plus b is greater than or equal to 0, or sometimes you might see it ax plus b is greater than 0 or greater than some other number. Ax plus b is less than or equal to something. Ax plus b is less than something. I draw my less than or equals to a little weird. A lot of the times you'll see it written like this. That's just my little oddity. I like to draw them parallel. So, how do we solve linear inequalities? Well, again, it's like solving a linear equation. Essentially, you want to get the variable alone on one side of the inequality. So get 1x, or just x, by itself on one side of the inequality. The only special rule is if you multiply or divide both sides of the inequality by a negative number, you've got to flip your inequality symbol. You got to flip that inequality symbol. Alright, and we'll remember that when we're graphing, with this textbook we use a solid dot to mark the endpoints. If you're graphing and we're talking greater than or equal to or less than or equal to, if you're including the endpoint, you use a solid dot. An open circle is used for the strict inequalities, meaning it can't equal. You may have seen in some textbooks they use brackets on the graphs as well. I don't have a problem with that, but in the software you may see it, you'll probably see it as the solid dot and the open dot. So, let's solve and graph solution of negative 2x plus 6 is greater than or equal to 14. Well, if this were an equation, we would subtract 6 from both sides, and so let's do just that. Subtracting 6 from the left side leaves us with a negative 2x. Subtracting 6 from the right side leaves us an 8. And since we didn't multiply or divide by a negative, our sign stays the same direction. Now we want to turn this into a 1x, so we'll divide both sides by negative 2. And when we do that, we end up with x, negative 4. But because we divided by a negative, we need to remember to turn this around. I like to do a little curly Q to say that not only did I flip it, but I did it on purpose. We end up with x is less than or equal to 4. Now we've got some different ways of denoting this. X is less than or equal to negative 4. One way is with set builder notation, the set of all x's such that, that's what the bar means, such that x is less than or equal to -4. Another way to talk about this is to use interval notation. In interval notation, we talk about the bottommost value and the uppermost value. In this case, x is less than or equal to -4, so the uppermost value is going to be -4. And since we are including it, since it's or equal to, we'll put a bracket there. Now we don't really have a bottom limit, so we'll say that that is -infinity. Finally, in graphing, we just need to mark a -4 on our number line, and we'll use a solid dot to indicate we're going, and we're going down. Sorry, I flipped that pretty quickly on you. Alright, another one. Graph the solution of x over 3 is greater than -2. Well, depending on whether you're multiplying by the least common denominator or you're just multiplying to use the multiplication rule, all we've got to do is multiply both sides by 3 and we get x is greater than -6. Now we've got this -6 on the right side, but because we didn't multiply by a negative number, we don't flip our sign around. Ways of indicating this: set notation, the set of all x's with the restriction that, or such that, x is greater than -6. Basically, you take what we have here, you say the set of all x's such that, and then write it again. In terms of interval notation, since we're looking at numbers bigger than -6, our bottom boundary will be a -6, and we'll put a parenthesis there because we're not or equal to, meaning we're talking about numbers that are just a hair bigger than -6, but we don't include the -6. And our upper boundary, well, we don't have one, so we'll say infinity. And anytime you use a positive or negative infinity, you use parentheses because we can't ever equal infinity. Putting it on a number line, put a circle because this is an open interval. We're starting at -6. Open interval just means we're not including the number -6. And we have our arrow going upward. Now, sometimes we will run across something called a compound inequality. You might hear me call it an inequality sandwich just because you have the boundaries above and below the variable, such as -2 is less than or equal to x is less than 4. That tells us that it indicates numbers that are greater than or equal to 2 that are also less than 4. So to graph that, we would have a -2, we would have a 4, and we're looking greater than -2, greater than or equal to, so we'll put a solid dot there. Less than, but not or equal to 4, so we'll put an open dot there. And we're looking at the values in between these two boundaries. And since I brought it up earlier, the way we would write this in interval notation is to say -2 up to 4. Now, to solve one of these inequality sandwiches, any action that you take on the middle, because our goal is to get that middle term to be just the variable by itself, just the x, anything you do to get that x by itself, you also do to the front third and the back third. So we need to do it to the right and left ends. Let's try one of those. Solve and graph the solution of negative 2 is less than 2x plus 4 is less than 6. Well, if this were just an equation where one side was 2x plus 4, the first thing I would do is subtract 4 to get rid of the constant. And I'm going to do that just the same, except if I do it to the middle, I also have to do it to the left end and to the right end. So negative 2 minus 4 gives us negative 6 is less than 2x is less than 6 minus 4 is 2. Alright, if I were just looking at an equation with 2x on one side, the next thing I would do would be to divide both sides by 2 to get rid of that 2. Well, I can do that with these as well, as long as I also divide the left end by 2 and the right end by 2. So negative 6 divided by 2 is negative 3, and that is less than x, and that is less than 1. I'm going to double check to make sure I didn't mess up my or equal to's. I don't have any or equal to's. These are both strictly less than. So I copied those correctly all the way down. I didn't divide by any negatives, so I don't have to worry about flipping signs. That makes this a little more difficult. In interval notation, that would be from negative 3 to 1. To graph it, I'm going to put an open circle at negative 3 and an open circle at 1, and I'm going to fill in the area in between.